All right, guys, this is the last new stuff that'll be on your test. Okay? This is the last new stuff. I promise. I mean, we're not going to get through all of it today, though. We're going to break it into kind of two parts. All right, so we're looking at adding and subtracting radicals. We're going to look at multiplying radicals. We're going to look at adding and subtracting with I and multiplying with I. Okay, we're going to look at all of that. All right, so when you're adding and subtracting radicals, they have to be like radicals. So it's just 3 radical 5, 7 radical 5. They're the same exact radical number. Just like an x, right? It has to be 7x and 3x if I can put them together. All right, same idea with radicals. It'd be exactly the same. Unlike radicals, 4 radical 3, negative 5 radical 2, one's a 3, one's a 2, they're not the same. Okay, so you're thinking about like terms, they have to match. Right? You may need to simplify, though, to determine whether or not you can put them together. So if I have like a radical 8, we know radical 8 can simplify. If I do my factor tree on it, it can change that. So number 1, radical 3 minus 5 radical 3. What is that? Say that again. Close. It's not just 5. Negative 4 radical 3. There's a 1 here. What's 1 radical 3 minus 5 radical 3? That would be negative 4 radical 3. The same way if that was an x, you wouldn't just drop the x, right? Okay? Right? Think about if I had given you x minus 5x. You wouldn't have told me that was negative 5, would you? I hope not. If so, we're in bigger trouble than I thought. Right? That would be negative 4x. So it's almost like that radical is acting like a variable. Okay? Whatever it is, it's just kind of staying that. So number 2, 4 radical 7 plus 2 radical 28, do they match? No. One's a radical 7, one's a radical 28. The way it sits, they don't match. But could I simplify them? If you do your factor tree on 28, that's 4 and 7, 2 and 2. Good, that's going to become 2 radical 7. Don't forget that's still there. All right, so that's 4 radical 7. Okay, so the radical 28 is not simplified. So we went ahead and did our factor tree. Pair of 2's came out. Left over 7, but this 2 was still there, so don't lose him. So 2 and 2 made that 4 radical 7. So now I get 8 radical 7. So bottom line, remember my rule of simplify everything you can first? Still here. Simplify everything you can first, and then put stuff together. So number 3, right now I have a radical 32 and a radical 18. They're not the same. So we need to simplify them. 32, so 2 and 16, 2 and 8, 2 and 4, 2 and 2, or whatever method you wanted to take. We're going to have a pair of 2's and a pair of 2's, which is 4. I have a leftover 2, and then I still have this 5. So I get 20 radical 2. 2, we have a leftover 2. Okay, and then we have the other one. We'll do a factor tree on the 18. So 2 and 9, 3 and 3. So a pair of 3's, leftover 2. Don't forget that's still there. So we get 12 radical 2. All right, just simplifying a radical at this point we should be able to do. Okay, all I did was my factor trees on the radicals. Kind of cleaned them up. Okay. All right, now are they like terms that I can put together? Yeah, 20 radical 2 minus 12 radical 2 is 8 radical 2. Will it always work that way? That when I simplify them, they'll become the same and I'm good? No. So don't assume it will, because they will not always. All right, take a look at number 4. Right now, are they like terms? No, they have different radicals. But let's try to simplify them. 24. 4 and 6. 2 and 3. 2 and 2. So that gives me a pair of 2s. Left over 2 and 3, which makes 6. Don't forget that's still there. So negative 8 radical 6. All right, if I simplify the other one, 8 just becomes 4 and 2. 2 and 2. So pair of 2s, left over 2. Don't forget you got a number out front. So 14 radical 2. Now can I put them together? No. So if they're not like radicals, you are done. I can't add those together. Do not try. Do not combine any of that stuff. If they are not exactly the same, you are done after you simplify. Thank you. Yep, sure can. You're slacking. All right, so is there any other questions on adding and subtracting radicals? Make sure they're the same, and if they're not, try to simplify them, and if they're still not the same, then you're done. Okay, but make sure everything is as simplified as possible. All right, we're going to move into multiplying next. Have we already practiced multiplying radicals together? Yeah, that first set of notes with radicals, right? We did simplifying radical, we multiplied them, and then we divided them. So we've seen those before. All right, so when multiplying radicals, you do not need like terms. This is where people panic. Adding and subtracting, they have to be alike. Multiplying and dividing, they don't have to be. Okay, that's how it is in math all the way across the board. People always forget that. You may use the distributive property, though, to multiply. So this one, I'm going to have to distribute, right? Radical 10 times radical 6 is what? That's radical 60. Radical 10 times 3, very good. That's going to be 3 radical 10. Remember, it has to be under a radical for them to multiply and actually change their number there. But I can multiply radical 10 times 3. It's just 3 radical 10. Just like x times 3 is 3x. Right, same idea. Am I good here? Am I done? No. They are not alike, right? One's a 60, one's a 10, but this one will simplify. If I do a factor tree on that, what do you have a pair of when you do a factor tree? Pair of 2's. So the 2 comes out, a leftover 3, a leftover 5, which is 15. Factor tree on the 10? No. So that's just 3 radical 10. Can I add those together now? I am done. They are simplified, and they are still not the same. I am done. Okay, so it's just kind of taking a lot of what we've done in the past, and we're just kind of putting a lot of this together today. Okay, why don't you guys try number 5 on your own? Just number 5. All right, so multiplying here, we'll distribute. Radical 2 times radical 6 is radical 12. Radical 2 times 5 is just 5 radical 2. Right, one's a radical, one's not. And then did you simplify anything? I hope so. The 12 can simplify. So we got a pair of 2's. Whoa. That moved everything. That's right. I'll redo it quick. All right, so we got a pair of 2's. Left over 3. Nothing to simplify there. Can I put those together? I heard yes, no. No, no, no. One's a radical 3, one's a radical 2. They're not the same. Don't add those together. Is she still the best at the table? All right, what about number 6? What the heck is that thing? It's long. Is it really much different, though? Do you guys know the F word in math? A 4-letter F word. Who said it? You watch your mouth. Did you hear what he said? Watch your mouth. You kiss your mother with that mouth? That is like a bad word to me. I hate that word. So first, outside, inside, last. It's how you guys learn to do it in Algebra 1. Right? Everybody's heard that. It's how they teach it. I hate that. Reason I hate that, what if I gave you something that had 2 terms here and 3 terms over here? Oh my gosh, that bad 4-letter F word no longer works. There's no longer first, outer, inner, last. Right? Okay. I would just, the reason I hate it is because of that reason. If I have 2 terms and 3 terms, suddenly like, oh my gosh, I don't know what to do with that. Just distribute. It's all you're doing. I'm distributing the first term. I'm distributing the second term. Okay? So for me, when I ask you how to do this, I don't want to hear the F word. Watch your mouth. Not fart. Don't do that either. Just tell me to distribute, okay? So radical 5 times radical 15. Radical 75. Radical 5 times negative radical 3. Negative radical 15. All right, and then we distribute the next term. 2 radical 3 times radical 15 is 2 radical 45. And then 2 radical 3 times negative radical 3 is what? Negative 2 radical 9. We can go one step at a time. The way it sits right now, do you have like terms to put together? No. But do any of them simplify? Yeah, we need to simplify. All right, so factor tree here. I know that's 3 and 25. So we get a pair of 5s and a leftover 3. Okay. Then I'll look at the next one. Can I do anything with the 15? No. So minus radical 15 and drop down. Next one, 45. Yeah, that's 5 and 9. 3 and 3. So pair of 3s. There's already a 2 out there. What's it become then? 6. I got one person paying attention. Thank you. Radical 5. And then, what's 9? What's square root of 9? That's just 3. So that becomes minus 6. Any of those like terms now? No. So what's that mean? I'm done. It's not pretty, but that is as simplified as that gets. It's tedious more than anything. It's tedious. All right, number 7, on your own. Well, let me talk you through and let's see how we did. All right, I'm going to go nice and slow. Some of you kind of walking around. Some of you jumped steps. You did it in your head. Totally fine, okay? I'm just going to go every single little step so I don't lose anybody. All right, so here we go. Distributing first. Radical 6 times 4 radical 3 is going to give me 4 radical 18. Okay, radical 6 times negative 3 radical 6 is negative 3 radical 36. Some of you kind of jumped right here, which is totally fine. Distributing the second part, negative 2 radical 3 times 4 radical 3 is negative 8 radical 9. Again, some of you jumped there, which is fine. And then negative 2 radical 3 times negative 3 radical 6. 2 negatives make a positive. Outside number, 2 times 3 is 6. Inside, 3 times 6 is 18. All right, there's your first step of just multiplying. Granted, the middle 2 you may have simplified right away. All right, from here, I noticed that I do have like terms sitting here. 4 radical 18 plus 6 radical 18 is 10 radical 18. What's the square root of 36? 6 times negative 3 is negative 18. Square root of 9 is 3 times negative 8 is negative 24. Again, you may have done your slightly different order, which is totally fine. Like terms, negative 18 minus 24 is negative 42. I'm going to go ahead and bring this down just to... Am I done right there? No. I have a radical 18 here that can actually simplify. So that's 2 and 9, 3 and 3. So pair of 3s, left over 2. That's still there. So I get 30 radical 2, and I had a minus 42. And then I am done. Again, you could have went different routes. Some people, when they work through this, simplified here and here first before they put them together. It's fine, right? This one would have given you 12 radical 2 if you simplify that one. And that one would have been, let's see, 18 radical 2. So, I mean, you still, that's fine. You could have simplified those first and then put them together. It don't matter. Questions? Did I lose anybody? Okay. Let's do one last multiplying one here. Number 8. Square root of 11 minus 2, that whole quantity is squared. Carrie, what's 5 squared? Okay, Olivia, what's 6 squared? Corbin, what is 7 squared? How did they know that? They didn't use a calculator. Every one of them did that in their head. Carrie actually said it out loud. I said 5 squared. What did you say? 5 times 5 is 25. So what does it mean to square something? You times it by itself. So this quantity squared means you times it by itself. So that means I have square root of 11 minus 2 times the square root of 11 minus 2. Every year, people try to distribute the square inside. You cannot distribute an exponent into a parenthesis that has a plus or a minus sign. Because to square something means to multiply it by itself. Okay, so we have to literally multiply that by itself. Right? Now it's just like every other problem that we've done. Radical 11 times radical 11. It's radical 121. Some of you jumped a step, which is totally fine. Radical 11 times negative 2. Negative 2 radical 11. Negative 2 times radical 11. Negative 2 radical 11. And then negative 2 times negative 2. Positive 4. Okay? Let's try. How'd you get a radical 2? I don't know. I have radical 11s going on in there. All right, what's the square root of 11? Or, I just told you, square root of 121. That's 11. I have like terms in the middle. What happens with those? Becomes negative 4 radical 11. And then I have a plus 4. Am I done? I got 11 plus 4 is 15 minus 4 radical 11. Now I am done. Yes. All right, questions on multiplying? No, but thanks for asking.